a virtual workshop for hacking agents. I am David Jones-Gilardi, developer relations engineer. Now, before we get started, I see people are coming in, so I'm going to give just a couple minutes for folks to kind of trickle in. I was also in the previous, all the previous talks and everything, and talking with a lot of you folks. And again, if you haven't already, now's a good time to go to the Discord channel, right? To make sure if you've got any kind of technical questions about what's going on in the workshop, ask them there, right? Let's see. Okay, like I said, we'll just give a minute. We're going to get hands-on. You can just watch. Totally up to you. All right, I see a pretty good amount of folks in. So why don't we go ahead and get started with our content? And by the way, just give me a thumbs up just to make sure that you can hear me okay and that you can see everything okay. I'm watching over there. I do see the thumbs up. Wonderful. Okay, again, like I said, I am David Jones-Gilardi. I'm a Gen AI nerd. I'm also joined today by Melissa Herrera. Now, you're going to be wondering, where is she? She couldn't actually be on the live portion of the stream, but she's going to be there in that Discord channel. So again, if you've got technical questions or anything, Melissa, my co-partner here, will be over in the Discord along with some others helping to answer any questions that you may have. Now let's take a look at our agenda, right? You just learned, for those of you obviously who came over from all of the lightning talks, you just learned, about all these various, like, say, agentic systems and everything like that. But what we're going to do is we're going to dig a little bit deeper and we're going to build some stuff, right? So the first thing we're going to have is a bit of an agents recap. What are agents? What are tools? And then a section that I think is super important are, what are the expectations? I'm going to level set with you about agents. Actually, some of the questions I've seen in the Discord, I definitely think we need to have that conversation, right? And then we're going to start hacking on some stuff. We're going to talk, we're going to figure out what is Langflow. We're going to build a simple agent. So you will, if you're doing this with me today, you will have built at least a simple agent and maybe even an agentic RAG by the time we're done. And then at the end there, we will, like I said, we'll build out a full agentic RAG agent. And don't worry, if you're not familiar with RAG or anything, we will also do a recap on that. So I'll help explain what RAG is. Yes, this will also be recorded. Okay, let's go ahead and take a look at the agents recap. So, I'm just going to pop all these up on the screen. If you happen to watch the keynote from CES a few weeks back, Jensen Huang, I'm starting there on the bottom. He said something I really, really liked when he was explaining agents. Very succinct. Agents that can perceive, reason, plan, and act, right? Or AIs that can perceive, reason, plan, and act. I thought that was a very succinct way to put what are agents. And if you look at the definition up there at top, that actually comes from a white paper from Google on agents. Matter of fact, I have, as part of this workshop, there are a whole set of resources that we've provided you. One of those is, in fact, that white paper. And they explain agents as a generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. But the key things I really want to point out there is, notice in both of them, acting, right? Observe, tools, reasoning, right? So this kind of forms the basis of what agents can do that are different from regular LLMs. Now, as you probably heard in some of the previous talks, right? Agents without tools would be a bit limited, right? And tools really bridge the gap between the agent's internal capabilities and the external world. It is the tools that give the agent, while it has agency, we'll talk about that in a second, its ability to then go out into the world and be able to, say, pull in new data, not just relying on the data that a particular model is trained with or something, right? So tools are pretty important in this particular setup. Okay, so by the way, I was being kind of tongue in cheek. If my visual of like what agents are like today, or I'm sorry, what LLMs are like, are pretty much, they're like walled in their own information, right? They're trained on some stuff. They don't really have the ability to interact with the outside world. But now, as LLMs are put into this kind of agent infrastructure, this agent architecture, now they have this ability. They're super excited, right, to go out and be able to interact with the world. This was AI generated, if you couldn't tell. I was having too much fun with this. All right, so let's go ahead and look at an actual chart, though. So this question actually came up from one of the users in Discord. I saw that kind of talking. Are we going to see anything that kind of explains like the architecture, what we're talking about when we say agents? This also comes from that same Google white paper that I was talking about a moment ago. So notice here in this agent runtime, you have the models. So the LLM, the large language model, is still a part of the agent. But where models on their own, again, don't have that ability to reason, they don't have, unless, like memory and things like that, they don't have the access to tools. This agent runtime adds on an orchestration layer that gives them the memory capabilities, it gives them the ability to reason and plan and such, and then tools. And then with those tools, right, these tools can be just about anything. So it could be an external AI search. It could be a Google search. It could be through the Wikipedia API. It could be from YouTube transcripts. I'm actually working on a project right now doing that very thing. It could be even locally, executed code, like a calculator or something. It doesn't always have to be something reaching out to the web. It could be a vector store. It could be something custom, right? So the ability now to wrap our LLMs in this agent runtime that includes the ability to interface with tools significantly increases their capabilities and what they're able to do. Now, I mentioned that level set part, right? Let's level set. Number one, not all models can execute function calling, right? So it just because, you're like, oh, okay, I saw your diagram. It's got a model there at the bottom and this whole agent runtime is around it. It doesn't mean that all models can do this. As a matter of fact, if I pop over, I'm just going to scroll down to the bottom of our Notion page here because I have the Berkeley page. So one of the resources that we've included here is this Berkeley function calling leaderboard. Because then the next question then is, well, if not all models support function calling or tool calling, then how do I know which ones do? Right. And they do a pretty good job. They usually keep things pretty up to date and everything. And they will list out this list here. I'm not going to go into detail of it. It's a resource. You can check it out. But it will it'll give you like the, based off of their criteria, performance, cost, all sorts of things, accuracy and that kind of deal. Which are the best, but then also which ones support tool calling. Now, the good thing is it turns out that for our examples today, we are going to be using OpenAI's GPT-4o and 4o Mini, and those happen to be here kind of at the top of the list. So that actually works out really well. But yeah, so it's just something to keep in mind that not all models can execute function calling. So it's something that you should be aware of. Now, another thing here is that tool name and description are important. When you interface, when you hook a tool up to an agent, the agent needs to know something about that tool. It needs to know what it does, right? So the name and description are important. We'll actually do some of that today. And this actually was another question that came up. Execution time might be longer than you're used to. Imagine for a moment, you have an agent that, say, is connected to a calculator. Well, that's a pretty simple, probably locally executed type of program or something to just do a simple calculation. But let's say an agent is connected out to a web search and you're asking it to go find various resources, that kind of deal. Well, it takes it a moment, right? It's going to have to go and it's going to have to go, find web pages, go scrape them, pull the data, collate the data, compose a response, all sorts of things. So the execution time might be longer than you're used to, depending on what you're doing. And that's something to really keep in mind when you're setting the expectations of what you think agents are going to do. And then this last one here is actually pretty important. You don't always need to build an agent, right? Matter of fact, so this also came up, there's the agentic flow or the agent hype going on. Like everyone's talking about agents right now. You may not always need to build an agent. If you can do what you're trying to do with a pure LLM and it's accurate and it's performant and stuff like that, and you don't really have a need to go outside of what that LLM can do for you, then you may not need to build an agent. As a matter of fact, agentic flows are more complex. There is more points that things could go wrong, right? So it's one of those things when you're thinking about, do I need an agent? Do I not? It's good to just keep this in mind. Okay, let's go ahead and get into some hacking stuff. So today we will be using, you've seen this nice little graphic, we're going to be using Langflow. What is Langflow? I think you've seen a bit of it today, right? It is an open source visual IDE. It's really a visual low-code, no-code way to build out Gen AI workflows. Now, for you coders out there, you can actually dig deeper. I'm going to show you that as we go through some of the flows. You can absolutely get into the code. You could modify the code. You can make custom code and everything. It is built on LangChain and Python, and it uses a lot of the vanilla LangChain, but it also extends it, right? So there's really a combination of both LangChain and then custom code and such like that. And then you'll see that it has all of these various modular components that you can use to very quickly and easily build out your GenAI workflows. What it's not a language model itself or an AI agent itself. It's a framework for building these Gen AI and agent workflows, right? And it's definitely not limited to a single AI model or vendor. It is totally model agnostic. It's vector store agnostic. Again, things I'll show you. The whole point of it is to make it quick and easy for you to be able to build your AI-based workflows with any model or vector store or whatever. Okay, so here's what we're going to do. Oh, thank you, Melissa. I see you sharing the Notion page, and we're just about to get there. So hopefully you all did the pre-work from the Notion page. If you did not, that is totally okay. What I suggest is you probably just follow along for now. You can always come back and do this stuff. So what I'm going to do is I'm just going to, I'm going to assume that from the pre-work standpoint that you've done the initial part, which is getting your Astra database going and stuff. Like I said, if you haven't, no big deal, just watch, right? And what we're going to do is I'm going to kind of scroll down here, and we're going to start with this simple agent. So there's really two ways to do this. You can either, one, just when you open up Langflow, and as a matter of fact, if you're here in Astra, if you've created your Astra account and you're here at your account, you'll notice up here on the top, you have this little drop down. You can just click Langflow. Now you can also, by the way, you can also just pip install Langflow. You can install it locally as well, but I'm going to be doing everything out of DS Langflow, right? DataStax Langflow, I should say. And if you click this, then you're going to end up with something that looks kind of like this, right? And that will bring you to Langflow. Now, like I said, you can start with the templates. This is like what Q was showing earlier, right? If I were to go to this new flow, you'll see that I get all these templates. You can start with that simple agent. Something else you can do, though, in the Notion page. Check this out. So if you go to this flow one simple agent, you see we included for every one of the flows here, we've given you an answer flow, right? So if you go to the JSON file itself, click on the little ellipsis and say download. If I then go over to my Langflow, where that new flow button is, and if I just drag this in, it'll just pop it right in, right? And then you can just go right to it. Okay, so that is another way that you can do that. Now, what I'm going to do is I'm going to build it from scratch. So, if you want to use the answer key, go for it, right? Nothing wrong with that. But I'm going to build it from scratch, and you can see if you can follow along. So I'm going to say, oh, and I see, thank you, Melissa. Okay, I saw a couple folks asking for the Notion page. Okay. All right, so I'm going to say Langflow in my particular case. Okay. Now, a couple things I want to point out here. I mentioned a moment ago that Langflow has all sorts of components, right? Model agnostic, all things like that. So if you notice on the left-hand side, you see all these various types of components. You have input, output components. You have models, like so many different model providers are supported here. Even Olama for local models, for those of you who are looking to do that potentially. It's the same thing for like vector stores and such like that. So what we're going to do is I'm going to start by building the simple agent, right? This is the one out of that first flow number one. So I'm going to start by bringing in my chat input and my chat output, because pretty much in any flow, I'm going to have an input and output, right? This is how I'm going to communicate with my agent. And then I'm going to bring in an agent, right? So I'm just going to pull in the agent component. You'll see on the left-hand side here, I have agents. I have this agent component, right? Now, if you don't already have an OpenAI key, you'll find that we do provide that. If you take a look on the Notion page, you'll see that in the steps here, make sure your OpenAI key, your API key is there. Since we are using that today, you'll need a key if you're going to do this. Now, OpenAI does now require that you put in a credit card, but it is like super cheap. Like the stuff we're doing today is going to be cents, right? As far as like cost goes. So it shouldn't be that huge from that standpoint. And actually the GPT-4o models are like super, they're super capable and they're really great for agentic flows. So I just suggest doing that anyway. So what I'm going to do is, in my particular case, I'm actually using a feature in Langflow that allows me to create globals. You could just type your key. You could just get your key from OpenAI's key, the API key section, and just paste it in here if you wanted. But what I do is I usually put those in globals. You could just say add new variable, give it some name, some name, and then credential, right? Because it's a credential, you want that stored securely. You put in the value and then say save, right? And then you will show up with whatever yours is. When you set it as a global, what's really nice about that is it will now become available to all of your components and all of your flows. You ever need to store it once, you don't need to worry about it again. Okay, so great. All right, so what I'm going to do is I'm going to hook up. I'm going to take the output of my chat input. This is the input. This is the user query. This is what I'm going to ask it to do. I'm going to wire that up to the input of my agent. I'm going to take the agent response. I'm going to wire that up to the output, right? Now I've got this full communication loop. But there's something missing. I need some tools, right? I need, again, the agent without the tools is, they can do more, but it's a bit limited, right? So in this particular case, what I'm going to do is I'm going to go to my tools area. I'm going to grab the calculator, bring it over to tools here. Okay, and then I'm going to go and I'm going to say URL. Now, something in Langflow, a feature, is that you're not limited. It sounds interesting, but you're not limited to just the components that are in tools for things to be tools. Like the URL component actually comes from the data ingest section, right? And you'll find that these components actually have this tool mode. So I can flip this tool mode on. And now I can enable my agent to actually search the web with this URL component. So now if we take a look here, we just break it down real quick. We can see that I have this kind of like basic setup, right? I've got my input, I have an output, I have an agent. I'm using OpenAI's GPT-4 Mini. I could use other providers, by the way, but I'm using OpenAI here. I've given it both a URL tool and a calculator tool. So now let's go to the playground. Let's try something. By the way, in the query, I'm going to say convert 200 USD to INR. Okay. Now that is in your answer, the answer flow. So the answer flow, it does have that example in there and such. Now you'll notice that as this is going, you'll start to see it. There it goes. And check this out. Let's see what it does here. Now again, all I did it was tell it to convert 200 USD to INR. I didn't actually give it any other instruction, right? I just gave it the URL tool and I just gave it the calculator tool. And check out what it did. On its own, it decided that it was going to go to an exchange rate site to get the latest data. And then it then used the calculation based off of what it found, and it actually gave me the correct answer. Now, how do I know that's the correct answer, by the way? Am I just telling you that's the correct answer? We're going to do that in a second. But what I really want to kind of illustrate here is the fact that the agent, again, powered by the LLM under the hood, but now with this ability to reason and plan and such, was able on its own to determine what tools it needed to use and give me the correct result in this case. Now, I don't want you to take my word for it. So that's the basic part. We're going to come back to this one, okay? What I want you to do now is we're going to go down. We're going to scroll down here to flow 2. This is the simple agent versus the regular LLM. I'm going to do the same thing I did before. Just download that guy. And we can come back over. Now I already have it here, but it's the same deal where I could just pop it in, drag and drop it in. It'll pop it right into your flow. So let's take a look at this flow. I'm going to collapse this real quick. Okay. So this flow it looks more complex, but it's actually pretty simple. Here on the bottom is the same exact agentic flow we just went through. I have my input, I have my agent, I have my 2 tools, and I have my output. But in the top, what we have is we have the same exact kind of setup, but this is with a pure LLM. This is using the same model, by the way. It's still GPT-4o Mini, right? We're doing that in both cases. We haven't changed that or anything like that. The biggest difference, though, is that this is the pure LLM, and then this is the agent, right? So if I go ahead and I run this, we'll go into our... And if you notice, by the way, I can do this a couple different ways. Notice that because I have the query here in my chat input here, I can just build it, right? Like I did here. I could just build the end. And and it'll run, or I can go in the playground and I can type with it and such like that. I can do both ways. Okay. Oh, and I guess I should mention here that the output, all this is doing is what we're doing is we're taking the output from both, we're feeding it in to this prompt component that I can use to set input variables. So in Langflow, anything that is encapsulated in curly braces, like you see here, LLM and agent, will be exposed as input variables like this, right? So it allows me to wire these up. So I'm just essentially changing the formatting. Again, all this is in the answer flow. So if I take a look, now I want you to check out what happened here. Notice what the LLM did, right? Without no agentic capability, right? And it says some things like, as of my last update, the exchange rate fluctuates, right? It kind of gave me an estimate based off of what it knew, but it did not give me the right answer, right? Where the agent, in fact, was able to figure out the right answer because of its use of tools and because it had the ability to reason and plan and figure out what tools it needed to use, right? So I think this is a really neat example of a case where using, if you're trying to compare the LLM, just the pure LLM compared to the agent. Now, are there ways to augment this with just an LLM? Could you use like a RAG or something, to pull in new data? Absolutely, right? But I think this really kind of illustrates one of the key differences between how agents operate and how just the LLM operates. All right. Okay, great. So what we're going to do now is we're going to go down to flow 3. Now this one, we're going to spend a minute in, right? We're going to be, because you've already built an agent, by the way, right? That simple agent, you've already built an agent. It's actually that easy. This is actually, I think, one of the areas where Langflow really, kind of shines, is it makes it very easy to wire this stuff up together and kind of get going with Gen AI and agentic flows. Now I'm going to build this one. It's the same kind of thing. So if you want to download this is going to be an agentic RAG. I'm going to build it live. And we're going to do a little bit of setup here first, because I've got to get data in the system. Now, I know that we were having some conversations about in the Discord with getting the data in the system. So here, we're going to go over that real fast. So what I'm going to do is I'm going to come over to my database. Now, again, this is if I followed the pre-work. If you haven't done this yet, that's okay. I would really recommend that you go and do it. And by the way, everything that we're doing here, when you look at the sign up and the Notion and stuff, it's all free, right? It's all free tier stuff. You don't have to worry about a paywall or anything. But once I have a vector database like I do here for this, in this case, what I want to do, I want to set up data. So for a RAG pipeline, I need a data source that I'm going to use to augment the generation of my LLM. Why don't we talk about that for a moment? So I mentioned when we talk about RAG, we're going to do a RAG recap, right? So RAG means Retrieval-Augmented Generation. And if we break down that acronym a little bit, what is that about, right? So, in the case that we just saw a moment ago with just the pure LLM, it did not have up-to-date information on the exchange rates and such like that. Now, let's pretend for a second that I have a system and I want to bring data into the LLM so it does have an updated context. It does know something about like my domain or something. So I can augment the generation of the LLM by retrieving data, right? And then changing its context. I can do that on the fly. That's what RAG is, right? And that's what we're going to do in a second. And it really is here to provide LLMs with domain-specific knowledge, whether it's your personal domain, your business domain, right? If you've got information that, is, specific to your business that may not be shared out on the internet or something like that, and the models haven't scraped it in or whatever, then this is the kind of information that you're going to want to be able to pull in potentially. It can leverage vector databases or other sources. We're going to do a vector database today. And vector databases, if you have not worked yet with vector embeddings and vector databases, one of the real like capabilities that they have is to return rich results from natural language queries. So unlike a keyword search where you can just, the ChatGPT experience, right? Where you can just talk to it. And then it's actually taking the text, it's taking what you say, right? It's converting that into those vector embeddings and it's doing a comparison somewhere against other things and return those results. That's happening most likely in a vector database or something like it, right? And databases are super efficient at doing this, right? So it can provide much richer results than you could potentially with just plain keyword searches, and it can interpret natural language, right? So RAG really comes into play when you're doing these kind of natural language types of things. You can also do a hybrid search, by the way. You can bring in keyword plus vector embeddings. Oh, I see Melissa has put up a question. How did the agent know that it had to call a URL to get an exchange rate and then use the calculator? Is it something it used GPT to figure out, or was it specifically coded? Yeah, it's not specifically coded into the agent. That is actually part of, it's a really great question. That is part of where that whole orchestration layer and such comes into play. So by giving it a tool, so one thing I didn't mention, I kind of glossed over this, honestly. I was going to get to it in a second. Notice that in the URL tool, it has a description, fetch content from one or more URLs. In the calculator tool, perform basic arithmetic operations on a given expression. So that description is actually used by the agent, right? So when you create tools, you need to name them and describe them appropriately so the agent knows what it's doing. It knows what the tool is for. So from that alone, the agent can then figure out what tool might be useful for a particular task, right? Okay. All right, so let's go ahead and let's start building this guy out. Now, before we do this, I need to actually get our data set in here. So if we come back over to the Notion page, I kind of went in a funny order. But one of the steps here in the Notion page, once you've created your database, right, is we're going to create this job listings collection. So in this particular case, what we're going to do is we're going to insert some data. We're going to put it into a vector store. That is then going to convert, in this case, for these job listings, like the description of the job into a vector embedding that we're going to store in our vector store. And we're going to use that to do these natural language searches for our RAG, our agentic RAG flow. So I'm going to go ahead and create that. And I'm going to say job listings. I know a couple of you already did this because I saw you in the Discord talking about it. Now, one thing I want to point out, notice here that when I create this collection in a vector database, that I, by default, have this embedding generator. This is NVIDIA. Now, you're not limited to NVIDIA, by the way, but this is the default. And what's really key about this, you don't need a key, right? Let me go ahead and just create that real quick. So in Astra, if I come over to integrations, you'll see you have all these different providers. You can use OpenAI or Mistral or something like that. And if I want to use one of those, I'd go get an API key from one of them. I'd plug it in here. And then Astra, natively, the database will handle all the embedding pieces, right? But the NVIDIA one, we actually pre-install for everybody, right? We house the hardware and everything. It doesn't cost you anything. It's just part of the database. So that's why I'm going to use that here today. And then I can see, it told me a second ago that, great. So now I have my job listings collection, and it's got the NVIDIA Embed QA model associated with it. So what that means is any data that is ingested when I tell it I want to vectorize something, or at query time when I'm asking natural language query, it will automatically convert that data into the vector embeddings using this model, right? And it'll handle that for me. So let's see how that kind of turns out. All right, let me do one thing real quick. Sorry, it was chilly in here and I had a heater on. It was blowing me out there. Okay, so now that we have that, right, what we're going to do is we're going to ingest the data set. So we have provided the code here. By the way, thank you to, if I can remember the name, Carlos Scar, for pointing out that I forgot to add a requirements text in for all of you. So when you go to run this load jobs listings py, you will need to pip install these guys, right? Because these are the libraries that we're supporting. So I added that to the Notion page because I forgot to do it myself. So I apologize for that. Anyway, so what I'm going to do is I'm going to copy this code. I'm going to pop it in here into my IDE. And then why don't we just real quick, just kind of look at what the code is doing. So all this is doing, this piece of code is going to pull a data set that we've provided you from Hugging Face. It's actually it's a LinkedIn job postings. It's actually, the total thing is like 512 megs, like almost 124,000 rows of data. I'm not asking all of you to ingest all of that. So what we did in the code is we filtered it down a little bit. We filtered it to just look for Python developer, software engineer, and data scientist. That way it keeps it within the realm of reasonable while we're doing the workshop, right? And then we've also provided that same data set here in Hugging Face, right? So it's here. You can go play with it to your heart's content and all that. Now you notice a couple things. Let's just open this up a little bit so you can see what's going on in the code. Okay. So for one, we want to connect to our database, right? So notice this AstraDB application token and AstraDB API endpoint. Where am I getting those from? So if I come back over to my database and I go to the overview tab here, right, you can see I have both the API endpoint and the token. This is all I need to connect and authenticate to my database. So I can just copy that, come over to my endpoint, pop that in, generate a token. I'm going to copy that, put it here. Now, in a real application, would I store these out in the open like this? No, I'd probably use a .env file, but for this case, we're just doing it like short and sweet. And then the name of the collection, right? This job listings here. The rest of this code, what it's going to do, I'm going to go ahead and start this, by the way, while we're talking. There we go. So the rest of this code, what is it doing? So, you know, we've got this big list of all of these job listings, and we're building an agentic RAG agent that is going to specialize in being able to pull data back based off these job listings. So what we're really going to do is we're going to iterate through each of those rows, right? The ones that we've filtered on. And in this case, I'm pulling out title, location, description. We're going to concatenate those together. We're going to combine them together into a single content variable. Do you have to call that? No, but I'm just trying to be consistent with the way LangChain does things with, you know, what they name content and everything. And then we're going to provide that. So we're iterating through all that data, and we're going to say, here that here's the content and this $vectorize. This is the important one. I'm telling the system now with $vectorize, this is the information that I want to convert into those vector embeddings. So if you're not familiar with that, what am I talking about? So if I come back over here, I should have some data. Yes, I do. Okay. So notice now I've got this content coming in, and you see these big arrays. If I go to the JSON view, you can see this a little better. So these are the descriptions, right? This is the description of the job posting. And you see here's this big vector embedding. So what's happening here is the database, because I've enabled it here with the MV embed QA model, on ingest, anything I tell it to use $vectorize is automatically being converted into this vector embedding. This now enables that natural language search, right? But there's a key piece. There's another key piece to this. It's the metadata. This is super important because when you go to do a vector search, you're going to return results based off of what is in those vectors. I'm only vectorizing the title, location, and description. But there's a lot of other information I want to bring in here as well. Things like the company, the max salary, the job posting URL, things like that. So I can use metadata to expose that. So when I return results, I get all of that back in a really nice object. I'm going to show that to you here in just a moment. Okay, so we're running through. Let's see. I see some. Okay, I'm just checking the. Okay, that finished. Wonderful. Okay, great. Okay, so I've got my data in. So now I have my RAG data, right? And I've got my data set that I'm going to use for my flow. So let's go ahead and start building this out. So what we're going to do, now you could just use the answer key. That was flow number 3, right? But what we're going to do is we are going to expand this a bit. So I'm going to open this way up. I'm going to move the agent over here. I'm just moving stuff out of the way, right? You could do this however you want. You don't have to do it like I'm doing it. Now, in the case so far, we just have a very we have a singular agent type system, but we're going to create a multi-agent setup. And why? Why do we want to do this? So, kind of a tip is, when creating agentic flows, you can have an agent do too much, right? If you muddy the waters and you give it too many tasks and too many tools and such like that, it may not always be the greatest at putting those results together, right? It really depends. So you can just overdo it. So one way that you can help solve for that is you can do a multi-agent flow. So what I'm going to do here is I'm going to make an agent, and I'm going to make this a tool. So I can do this tool mode again, right? I'm going to flip that into tool mode. You see now it goes to a tool. I'm going to make this a tool of this agent, right? And then in this case, I don't have to do what I'm just about to do, But GPT-4o is actually a better model for doing the planning and the resource part and that kind of deal. So what I'm going to do is I'm treating this like my master agent, like my orchestrator. This is the thing that's going to be the planner, right? I'm also going to add a bit more instruction to it, right? So, all the agents come with a base set of instructions. If you look at this, right, that you're a helpful assistant that can use tools to answer questions and perform tasks. But I'm going to give it a little bit more. Again, this is coming out of the answer key. And I'm just telling it, how do I want my output? If you can't find relevant information, search the web, and giving little nudges, right? One thing that I find that is really important sometimes is I've had varying degrees of success with this with different models, but sometimes I have to tell them don't hallucinate. I just do that as kind of like a de facto standard. Some models are really great at this, some models aren't. So I just do that as like a standard. Okay, great. Now, would this work with GPT-4o Mini? Yes, but GPT-4o tends to be a little bit better at, like I said, the resource and planning part. Okay, I'm gonna add my OpenAI key here. Now, these instructions aren't quite what I need for this tool, right? Because now this tool, even though it's another agent, I want it to be something specific. So remember I said earlier that it's sometimes better to give agents specific jobs, focus it narrowly on a task, make it really good at that task, right? That's what we're doing here. Okay. And then what I'm going to do here is in the instructions, I don't want it to just be a general assistant that can use tools. I want it to be a data lookup for LinkedIn job postings, right? And then the final thing here, actually, that I just made a mistake. I actually mean to go here. Where's my description? I'm going to turn the description on. There we go. Yeah, we're going to override the instructions in a second. This one, this is the one I meant. The description. Remember I said the description and the name are important. Yeah. So this is the description. My bad on that one. Okay, great. So now we have our agent as a tool. Now the trick though is that we haven't actually powered it with anything, right? It doesn't have any RAG data yet. We haven't done that part. So what I'm going to do is I'm now going to hook this flow up to our vector store, right? The one, the job listings collection that we just created with that data in it, we're going to hook that up, right? So I'm going to come over to my vector stores. In this case, I'm going to use AstroDB and pull that out. Now, I recognize that some of you may or may not be using the DataStax Langflow through Astro. You might be using it locally. So what I'm going to do here is I'm just going to, we generate a token for you. We do that part, so it just hooks it up. But I'm just going to go ahead and pull that out. And I'm going to go back to my code because I already did this, right? And I'm just going to grab my token right here. Again, I would save this in a global, most likely. And then I'm going to say choose a database. I'm going to pop Agentic hacking database. It's going to now, okay, I know it talked to it. I want job listings. Okay, great. So that's part of the setup. Now, what we're also going to do is we're going to wire up our user query into the search input. Why? Because when we start asking questions, it's those questions that we want to input into the vector search to get results that are relevant to the RAG pipeline, the part of the RAG pipeline we have here, right? And then the last thing I want to do is it'll say, hey, you need an embedding model. Well, guess what? We already have one, right? We set one up here. We already provided the embedding model through Vectorize. So here in the component, you choose Vectorize. You tell it which one. And then it's the NV embed QA. The rest of the stuff we're not going to use, so I'm just going to turn all that off. You don't have to turn it off. I just like it to be a little cleaner. Okay. And then I'm going to turn just a couple other things on because there are things that we might want to control. I'll explain these, like the number of results, search type, and the score threshold. Do you have to do that right now? No, it's not a big deal. Okay, no, so as a quick test, what I'm going to do is I'm just going to grab one of the queries from the answer key. I'm just going to put it in here, and I'm just going to go, okay, let's test this out real fast, right? So what I want to say, boom. Okay, great. So I just asked this question, find me the top 5 software engineer jobs available in Chicago and provide the company websites. Now, all I did was the vector search. But let's take a look at the results. Check that out. I've got software engineer. These are all coming from the data set. Now, I just asked to provide the top 5, but it only gave me 4. That is exactly why I enabled this number of results field, right? So maybe I want 20. or something like that, right? Because, you know, in a case like this, I might want like a set of them, right, to make sure that then I'm getting, you know, enough data to kind of make intelligent, you know, give the LLM and the agent enough information, right? So now you can see I've got all these greater Chicago area software engineer positions. Super cool, right? So now I have the data portion starting to work, right? And you can actually see that the query was pretty darn quick for the fact that it did a natural language query here. All right, so what I want to do next, though, is I want to get this to my agent. We haven't gotten it to my agent yet, right? So notice here my results. You'll see these little nodes. So in Langflow, if you click on a node like this, it'll actually show you, to tell you what kind of node it is. It's a data node in this case. It'll show you all the other components that are compatible with that, right? So what I really want to do, though, is if you take a look in the results, if you may have noticed, job title, company, max salary, job posting URL. Did those look familiar? They are these. They are the metadata. So what happened here is by using the metadata, when we get our vector results back, we also return that metadata in this nice object. That's why I tell you to do that, right? So this makes it great because now I have other, so instead of just relying on the information that was in the description, because not everybody provides the salary or the job posting URL or something in the description, right? So I can use the fields that were in there in that metadata to now round out the data and make sure I have like a consistent response. So now we can use these, but this is a data object. So what I need to do is I need to parse that data object. I'm going to parse data. I'm going to just wire this up. Okay. Now it starts off with text. So if I did nothing, I'm going to, by the way, a little trick, I'm going to freeze the path right now. Why? Because I've already got the data set. I'm going to iterate and experiment for a moment. So I've already got the data set that I need. I just want to iterate on that. So I'm going to freeze the path so I'm not paying the cost every time of regoing and doing the search over and over. But I'm just going to test this out real quick. Now, parse data in this case, you see that curly brace text, right? So it's saying, hey, I just want the text field. Well, some of them might have compensation, but most of them don't, right? So if you remember in that metadata, we have all, the text is just one of the fields, right? Right? I have all these other fields I have access to. So what I want to do is I'm going to, and this is so I'm setting up the agent to have a nice set of data that nice consistent data that it can pull from, right? So now I'm setting up these name value pairs. Again, notice the curly braces with the field values. These match my object exactly, right? My data object. So you'll see that I have like job posting URL. They match those. That's all you have to do. And now when I build that, here it goes. Now I have this really nice structure, right? Very consistent, nice structure. This will definitely make, it'll make the output from my agent be a lot more accurate and a lot better, right? Because it's able to use that structure. Now, finally, what I want to do is I want to get this data. I mentioned earlier when I made that mistake earlier that I was going to I was going to update the agent instructions here, right? Because now we need to give this agent some instructions. We're going to tell it what its job is, but we're also going to provide it the RAG data, right? We're going to provide it the retrieved data that it's going to use to augment its generation. So what I want to do now is I'm going to use a prompt component. Okay. Okay, now, wait a minute. How do I wire that up, right? It looks like I can't. Well, it's because I need to give it an input. So what I'm going to do is this is where I'm going to give it a prompt. Again, this is in the answer key. There we go. Now notice here's the instruction. You are a personal job finder specializing in finding jobs posted on LinkedIn. This is your task. There's also some key things in here, right? For each match include the company name, location, salary. That's coming right from that metadata, right? So it can do that consistently. This one here, I find to actually be really important, especially in a multi-agent setup where I'm using an agent as a tool. For my case here, I don't want it to hallucinate anything, and I don't want it to pretend like if it doesn't have results for a query, just tell me you don't, right? Because that way, the orchestrating agent can use that information and recognize whether or not it needs to do more, right? Notice in the instructions that I have for my orchestrating agent here, I said, if you can't find relevant information, search the web for images and URLs and stuff like that. So I'm trying to set it up in such a way where if there were no responses for something, maybe the query just didn't respond in a result or return in results or something like that, that the orchestrating agent knows better what it can do with that, right? And now that I've, if I look back at this prompt here, you see that I have the job matches. So these are all the matches we got. Again, I'm exposing that in the curly braces as a field variable. So it'll, boop, I just wired up. And now these are my instructions. So if I come and build this, what'll happen, as you can see, I have the new instructions and I have all the data, right? And now this would be the agent. That's what I meant, that mistake I made earlier. Now we're wired up, right? We're totally wired up. So if I were now to come in, let me go ahead and turn off where I froze it. Let's see. Oh, I thought I froze it past further. Okay, it's playing the I'm not going to respond to you games. I'm just going to refresh that real quick. I don't know if I use, what do you call it? Arc or what? All right, let me, by the way, how are questions going? Let me tick real quick. Okay. I love the loading page of death. That's always fun, right? Let's come back here. Okay, that was weird. Try that again. Okay, yeah. All right, cool. Yeah, that was weird. All right, we'll hook that back up. Okay, great. And go over here again. There we go. Yeah. All right, so now if I start asking some of these questions, I'm going to grab the questions that are actually in the, I'm going to grab the questions that are in the answer key. And let me go ahead and just clear these out real quick and say, if I work as a back-end engineer with an annual salary of 120,000, how much will I make monthly after deducting 30% for taxes? Now, what's interesting in a case like this, right, is does it need to go get data? See, this is where the agentic flows are really, really powerful, or can be really powerful. Notice that it just did some math. It didn't actually need to go to the job postings agent because I didn't ask it for job postings, right? So again, this is something different than a pure LLM would do. Let's go to the next one. Now, by the way, I tend to use, I use new chats for each of these to keep them clean. So I'm just going to do that again. Now I'm going to use that same query before that. Find me the top software engineer jobs available in Chicago and provide the company websites. Now this one should in fact go through the RAG pipeline. Let's see. Oh, here it goes. Now remember I mentioned before that sometimes it can take a moment for agents to do things. And again, there's a lot going on behind the scenes, right? It's getting responses to RAG data. It's then got to collate that data. It's got to, it's like there's all these little jobs. So if you actually look at the log output and such like that, you'll see that it's literally having a conversation with itself, right? Now check out what this did. So it went and used our job listings agent, right? This is the query that it passed over to it. And look at the data that it gave back. And then you saw that it used the URL fetch content. Why? Well, remember, I told it in the instructions that I want you to find jobs. I want you to find the company site as well. So in the markdown, I'm sorry, not the markdown, in the, I just all of a sudden had a total brain fart. In the metadata, there we go. In the metadata, we include the LinkedIn job posting URL, which is exactly what you're seeing here, these job URLs. Right? Check that out. It's actually giving me directly the job URLs. That's coming from that metadata, right? But now what it also did is since I asked it to get me the company websites, right? It is going out and finding the company websites for each of these job postings. That is not in the vector data. That is not in our RAG data. The agent figured that out itself. So in this case, compared to the last query we did, it was able to determine that it needed to use the job postings agent and that it also used the URL, I should say the job postings agent tool, but then also the URL tool to do this, right? and it's giving me, the ones that consider the top 5. You gotta, if you want to narrow that down, you give it some criteria and everything, right? Okay, and then this last one. Oh, and I should say, here I'll kick this off, but let's get a question here. But this last one, if you take a look at the data set, you see we all got all these Chicago things, right? So it's doing that here. And okay, I see a question here. Still not quite sure why build agents. We can just use LLM plus RAG. What's the advantage of agents here? Yeah. So, and by the way, that's a super valid question. LLM plus RAG absolutely augments the knowledge of the LLM. So could I, in a case like this, could I build out a flow that just does this, does the job listings kind of thing as a RAG pipeline? Yeah. But then if I wanted it like it did, so remember the results I got a second ago here, where I asked it explicitly to go get company websites and do other things? An LLM with RAG could not do that. It's the agent with the URL tool that is then able to do that, right? And then you add on the calculator tool and other tools and such like that, and you can start to expand their capabilities pretty greatly. An example of that, by the way, is this next one. So I just asked it here, are there any jobs for data scientists in the database? If so, what's the highest paying job, and what is the expected salary difference compared to a role paying $200,000? So again, it went off, got all these job listings, from our RAG pipeline, the RAG agent, if you will. And then it sees this difference here, right? It figures this out. Now, what's interesting, again, going to your question about RAG and LLM, is some models can calculate that. Some models cannot, right? So if you have an agent with a calculator tool, then it is more apt to have the right answer because it has a tool at its disposal that it can use to do the calculation. So it really does, it really extends the capabilities. But going back to something I said originally, if you don't need to use an agent, don't. It's more complex. It could be slower in some cases. It might not be. It depends, right? It is one of those things you have to like iterate and experiment and stuff. But no, it's a great question. Great question. Okay, great. So, I mean, now you see here that we've got this agentic RAG. So we've got a multi-agent setup with agentic RAG. We're able to pull from a vector database and ask, these really interesting, natural language queries that we are now able to get some pretty well structured and accurate responses from. Definitely more than I could do with just a pure LLM. And I would argue more than I can do with an LLM plus RAG, especially when I'm asking it to do other things like get websites and calculate things. All righty. All right. So with that, resources. So I mentioned before, these are, by the way, these are also in the Notion page. If you go to the very, very, very bottom of the Notion page, you'll see there's all sorts of resources here. This first one, I find this is an excellent resource. If you're gonna, if you're looking to run agents in any kind of sense and start building them in production and things like that, this site has such great tips and tricks and a lot of considerations to keep in mind. So I would highly suggest taking a look at it. The Berkeley function calling leaderboard, again, to keep an eye on those models that do have function calling. By the way, I saw a question pop up earlier. I just couldn't answer at the time. You might see some models that are on the function calling leaderboard and you're like, well, why don't I have access to them? Not all the models are publicly accessible and such like that. Some of them are Berkeley's own, things like that. You can use a llama a lot of the times. Matter of fact, one of the ones that's on the leaderboard is Quen25, which I've actually found is a great model for using local models. You can do that with a llama, right? So a really nice resource to kind of keep up on. The Agents white paper by Google, that again goes deeper. So if you want to learn more and more about like agents and tools, you want to go level deeper than we probably have here today. It's a great white paper for that. And then finally, we don't really get into it here. We did agentic RAG, but this last one goes into doing hybrid search with RAG. So that means where you're adding in keyword, you're combining that kind of capability. And you can do this to really filter down and get very accurate results. Let's see. Okay, so finally, if you haven't already, sign up for Langflow. It's free, right? You can, all the stuff that we're doing here, you can do, you can do all of this stuff. You can also, again, go to langflow.org. You can get to the GitHub repo from there, and you can just pull it down. And that we have an OSS version. It's the same, honestly, as what's up on DataStax Langflow. Just that in DataStax Langflow, we host it for you. In OSS, you install it yourself. Either way is totally viable. And with that, everybody, thank you so much for joining us today. We really, really appreciate you spending some time with us in these so many hours and everything like that. We cannot wait to see what you all build, and come talk to us in the Discord and let us know what kind of agentic flows you build. Take care, everybody.